Here we are, 7.3 notes example 4, and although we've done a lot of work and calculations on the unit circle, this is just like a closing thought, and it's not as hard at all. You see all this space, don't be scared, okay? Described below are angles in standard position. Standard position means they just begin at 0 degrees, okay? They begin here and go up. Determine which quadrant, that's your goal, which quadrant or on what axis each angle terminates. That means ends. Give an explanation to clearly justifies your reasoning. If no such angle exists, explain why. All right, so if the cosine is greater than 0, that means the cosine is positive, right? A positive cosine. Now what's cosine equal to on the unit circle? Cosine is equal to the x value. So we want to know what quadrants are the x's positive, right? So if you make a little chart, where are the x's positive? X's are all positive in quadrant 1 and in quadrant 4. Do you agree? Okay. And we're talking about the same angle here. So where is the cosine positive? Cosine's positive over here, because cosine's equal to x. And now we want to know, wait, where is the tangent negative? Well, the tangent, what's the definition of tangent? Definition of tangent is y over x. Y over x. So tangent will be negative when these signs are different. So either positive over negative or negative over positive, right? When they're the same, the tangent will be positive, but when they're different, tangent's negative, okay? So think about your quadrants. Here we have positive, positive. Back here it's negative, positive when we're talking about x and y's. Over here it's negative, negative. And over here it's positive, negative. Is that right? Double check. Yes. Okay. So where do the tangents, we want the tangent to be negative, so where do they have different signs in what two quadrants? So in quadrants 1 and 3, this is 2, 3. In quadrants 1 and 3, they're the same. So in quadrants 1 and 3, tangent is positive, but tangent is negative in quadrants 2 and 4. Okay, so since x is greater than 0 and y divided by x is less than 0 in quadrant, what's our answer? Our answer here is quadrant. Cosine's positive here and here, and the tangent is negative here and here. So the answer is quadrant 4. And I think I have bad English. Since x is greater than 0 and y over x is less than 0 in quadrant 4, theta, that's a theta, is in quadrant 4. How about that? Good. Long explanation. Okay. So where is cosine positive? We already said that that is in quadrant 1 and quadrant 4. And where is tangent undefined? Okay. Tangent, what's the definition of tangent? Y over x. How would you get undefined? That's when we would get 1 or negative 1 over 0. So when we divide by 0, that's when tangent is undefined. Where is x equal to 0? The x value is equal to 0 at when theta equals, get out my little mini unit circle here. Where is x equal to 0? Let's see. We're looking at the coordinate points. X is equal to 1 here. So x is equal to 0 here and here. Oops, sorry about the bell. So x equals 0 when theta is pi over 2 and 3 pi over 2. That's not in a quadrant. Those are on the axes. So cosine is positive. I'm trying to do a video. In quadrants 1 and 4, but tangent is undefined at these angles which are not in quadrants. So does this angle exist? Theta does not exist in this scenario because cosine positive in quadrants 1 and 4 and tangent is undefined on, can we say on the y-axis? Yeah, up here and down there. All right. Isn't it fun to learn? Okay. Where's tangent positive? Go to our little chart here. Tangent is positive. So where is y over x positive when they have the same sign, right? So they have the same sign in quadrants. Where does x and y have the same sign? Quadrants 1 and 3. All right, that's our answer to that. Okay, let's talk about cosecant. Cosecant is the reciprocal, that is an unofficial symbol for reciprocal, is the reciprocal of sine. So when you're talking about reciprocals, the positive and negative will just be the same, all right? Because, let's see, if negative 1/2, what's the reciprocal of that? -2, right? So the sign is the same. So the cosecant will be negative wherever the sign is negative. Now, what does sine stand for on the unit circle? Sine stands for y values. So where are the y values negative? In what quadrants? Quadrants 3 and 4, right? Quadrants 3 and 4. I really like this example. This is fun. Okay, so where is theta? Theta is the tangent's positive in quadrants 1 and 3, and the cosecant is negative in quadrants 3 and 4. So where is theta hiding? It's like a game, right? Theta is in quadrant 3. Yay! Because tangent is positive and cosecant is negative. Conclusion. All right, one more. Sine is negative. We just did that, right? We just did sine is negative. You could see, guys, a lot of this is going to be repeating. So y is negative in quadrant 1, 2, 3, and quadrants 4 below the x-axis. And secant is the reciprocal of what? Cosine. Where is cosine undefined? I'm confused. The teacher said the cosine, let's see here. Oh, secant is undefined. Okay, let's see here. Watch. If cosine is x, what's cosine? X, yes? Okay, then what's secant? Let's go backwards now. Then secant is 1 over x. So remember me saying sometimes you're going to flip a fraction and sometimes you're going to think about it as 1 over x. So can secant be undefined? Yes, secant can be undefined when x is what number? 0, right? Let's write that down. Secant is undefined when, that's not how you spell when x equals 0. Because cosine is x, secant is 1 over x, so secant will be undefined when x is 0. Belle, you're bugging me. Okay, where is x equal to 0? X is equal to 0, not here, but again at pi over 2 and 3 pi over 2. Now, are those in a quadrant or are they on the axes? It's on the axes. So secant is undefined when x equals 0, which is when theta equals pi over 2. Oh, yeah. There's supposed to be no announcements today. Okay, pause. Okay. On C, this landed on an axis and we said that the theta doesn't exist. But on D, this one does land on the axis at pi over 2. No, just kidding, 3 pi over 2. But the question is, watch. Look at 3 pi over 2. Ready? Is the y value negative? Yes, the y value is negative. And is secant undefined? Yeah. So instead of this being in a quadrant or in 2 quadrants, the only place where this can happen is actually at this point, at this location of 0, -1. Do you get that? So that's why we wrote it down. Okay, I'm going to move along here. Suppose this is true. What does this mean? This means that you're only looking between pi over 2 and 3 pi over 2. What quadrants are those? Here's pi over 2, and we're going down to 3 pi over 2. So only in quadrants 2 and 3. Sine is equal to 1/2. Oop, find that. Where is sine? So look in these 2 quadrants. Sine, what value is sine? Y. Sine is 1/2, where? Right here? Okay. So what is the value of theta? So we know sine is 1/2. Theta, we're going to only look at the radians, 5 pi over 6. Why did they tell us to only look here? Is sine equal to 1/2 over here also? Yep, but we're not going to use this one. It told us to look between pi over 2 and 3 pi over 2. So theta is equal to, theta is equal to 5 pi over 6, and write down the coordinate point. The coordinate point is -3 over 2, comma 1/2. And it's 150 degrees, but we're not going to be talking about degrees very much. We're going to be looking at radians most of the time. What is the value of theta? Check. Determine the exact value of the other 5 trig ratios. What? Okay, so we're going to do all of them. Are you ready? Sine. What's sine equal to? 1/2. What's the cosine? That's the x value, right? -√3 over 2. What is the tangent at this point? Did you write it down on here? Do you have that from class today? The tangent, I'll show all the work, okay, in case you missed it. The tangent is going to be y over x. If you have it memorized or you have it written down, then you don't have to do all this work, which is the 2's cancel and you get -1 over √3, and then you have to rationalize the denominator. I always rationalize in a different color, like this. Okay. So the tangent now is -√3 over 3. We're going to do all 6 trig functions. So those are the first 3. Now we're going to do the reciprocal ones. So the reciprocal of sine is cosecant. And what's the reciprocal of 1/2? 2. The reciprocal of cosine is secant, and that's going to be -2 over √3. Bummer. What do we have? We have a square root in the denominator, so we're going to rationalize again. -2 √3 over 3. Okay. It's not as organized as I'd like it to be, but we have 1, 2, 3, 4, 5. We still need a 6th one. We still need cotangent, and I have room down here. Cotangent, you ready? Do I want to do the reciprocal of this one or the reciprocal of this one? If I do the reciprocal of this one, won't I have to rationalize the denominator again? Yuck! So I'm going to take the reciprocal of this version. So what's a reciprocal of -1 over √3? -√3. See? So that's all 6 trig ratios. Okay, I don't have time to explain the homework further, so you're going to have to read the instructions. Find a coterminal. How do you find coterminal angles? Add or subtract 2 pi. Okay, good luck on the practice.